Alright, folks, welcome back. Today, let's talk about what the heck is negative frequency. Today, we're broadcasting on negative 98 megahertz. Negative frequencies really don't make much sense. And when we're talking about the frequency of a sine wave there, I agree. Negative frequency makes zero sense. But let's not think about sine waves for a minute. Let's just think about a simple rotating wheel. That rotating wheel is going to have a frequency, the frequency at which it rotates. And the positive or negative frequency is simply just going to indicate what direction is the wheel rotating. So a positive frequency means the wheel is rotating counterclockwise, and a negative frequency simply means the wheel is rotating clockwise. So in this example, we can see that the positive and negative frequency simply is a way to describe what way is the wheel rotating. Well, how can we describe a rotating wheel mathematically? In comes the complex phasor. So we're simply using mathematical, imaginary or complex numbers to describe that motion. We're simply using this math because it already exists and it's very convenient. So the rotating wheel is just a way of describing what direction is the wheel rotating. And we'll get into this later, but negative frequency really only makes sense when you're talking about IQ signals, either in an IQ modulator or a IQ demodulator. And let's try to explain it this way. So let's say we have three broadcast FM stations. One's at 88.1, the other one's at 88.9, and the other is at 89.7. Nothing scary there, hopefully. But now let's say we want to describe them relative to 88.9. So obviously the frequency at 88.9 is 0. The guy at 89.7 is 0.8 megahertz above, and the frequency at 88.1 is simply negative 0.8 megahertz below 88.9. So this is how you describe frequencies with respect to an arbitrary frequency. In this case, we've chosen it to be 88.9. So now you can start seeing a negative frequency is used to describe its relation from another frequency. That's all it is. So how can we create these three signals? Well, one way is we'll get three oscillators and tune them to the separate frequencies, add them together, and voila, there you have three FM signals. Now you might think that's no big deal, but let's say you have now 1,000 frequencies. Hopefully you quickly are seeing that this method is rather expensive and, stupid. So how could we create the three FM signals using one IQ modulator? And that's where the negative frequency comes in. We simply add up the three rotating wheels, add them all up, and send that through the IQ modulator. And we're describing the offsets relative to our center. In our case, the center is 88.9. So simply add the three rotating phasors, and there you go. I should also mention this spectrum is also what you will see on the receive side, right? If you tune your SDR radio to an LO of 88.9, the station at 88.9 will basically have 0 hertz because it's exactly at that LO. The radio signal that's at 89.7 will have a positive 0.8 megahertz offset. And the signal at 88.1 will have a negative 0.8 megahertz offset. So here the negative and positive frequencies are simply used to relate them to where the LO is. That's all a negative frequency is. I can throw you a whole bunch of math, but negative frequency is simply used to describe a signal relative to another signal or frequency. That's it, folks. Simple as that. Thanks for watching.